Unit 5, Lesson 1, First Differences in Graphing Linear Relations. So the goal for today's lesson is to teach you guys how to calculate the first differences from a t-table, or a table of values, and then to understand the relationship between the first differences that you just calculated and the way the graph looks. So I want to define linear relations. So a linear relation is just a special kind of graph. It's a graph whose points always form a straight line. So anytime you see a graph and the points form a straight line, you know it is a linear relation. Okay, so here we have a t-table. Okay, in grade 9 we call it a table of values. Remember, it's a x column and a y column. So it's just a bunch of points, right? Because points are x and y values. So this would be a point, right? It's 0, 5, because it's the x value and the y value. This would also be a point, 1 and 8, 2 and 11, and 3 and 14. Okay, so when you're given a table of values and you're asked to calculate the first differences, the way you do it is you subtract the y values from each other, okay? Because the first differences are the difference between the y values. So I want to calculate the difference between 8 and 5. So you take the second y value and subtract the one above it. That's how you calculate the first differences. Okay, and then 11 minus 8, so the second one minus the one above it. And finally 14 minus 11. Okay, so that's how you calculate the first differences. Okay, so calculate the first differences and then graph the data. So we're going to do that and we're going to learn about a relationship between the first differences and the way the graph looks. So remember, to calculate the first differences, take the second y value, subtract the one before it. Okay, so all of our first differences are written right here. Now let's go ahead and graph the data. So remember, to graph the data, we only use the x column and the y column because that's what makes up our points. The first differences have nothing to do with the actual coordinate point. Okay, so the points that we're going to plot are as follows. The first one is going to be 0, 2. So 0 and 2 is right there. Then 1 and 4, so right there. 2 and 3, 3 and 6, 4 and 9, and 5 and 11. Okay, so just looking at this graph, is this a linear relation or not? Okay, hopefully you realized it is not a linear relation, right? There's no way that we can connect all of these dots and form a straight line. They're kind of scattered all over the place. They're definitely in an upward trend, but they're not in a straight line. Okay, and all I want you guys to realize right now is you just told me that this is not a linear relation, and I want you to notice that just so happened that the first differences were not the same. Maybe there's a connection between the first differences and if the graph is going to be linear or not. Okay, we're going to investigate that a little bit further. Let's try this one, example 2. Calculate the first differences. So take the second y value and subtract the one above it. Okay, so the first differences all ended up as -2. Let's go ahead and plot the points. So the first point we're going to plot is -2, 3. Then we're going to get -1 and 1. Then 0 and -1. 1 and -3. And 2 and -5. Okay, ask yourself, is this a linear relation? Okay, it definitely is because you form a straight line. Okay, and notice the connection, right? This was a linear relation and all the first differences were the same. Maybe that's not a coincidence. All right, the last one. Quickly calculate the first differences. Let's take the second y value, subtract the one above it. Okay, first differences are not the same, so hopefully you can start to guess if the graph's going to turn out linear or not. Let's graph. So -2 and 11, -1 and 5, 0 and 2, 1 and 4, 2 and 11. Okay, definitely a non-linear relation because we cannot draw a straight line and connect all those points. Okay. All right, so in summary, how can we tell whether a relationship is linear or not based on the table of values? So what you should have seen, and we did see this happen, if you calculate all the first differences and they end up all being the same number, the relationship will automatically be linear, so it will be a straight line on the graph. If you calculate the first differences and they're not the same, the relationship on the graph will be nonlinear. And we saw that happen in every single situation. Okay, here, first differences were not the same, nonlinear. First differences were the same, and our graph was linear. First differences are not the same, graph is nonlinear. Okay, so that's the rule that I want you to take away from today. So if ever you want to see if a set of data is linear or not, just calculate the first differences, and if they're all the same number, you know it will be linear. Okay, independent versus dependent variables. So we need to do some definitions first. Okay, so a variable is just something that changes in a relationship. Okay, so a lot of times mathematicians use x as a variable, but just know that you can use any letter as a variable, and it always represents something that's changing. So there's two types of variables. There's an independent variable and a dependent variable. Okay? So an independent variable is a variable whose value changes on its own accord. So it just changes, and it doesn't change because of something else. For example, time. Okay? Time just changes as we go through our day. It just changes from 8 o'clock to 9 o'clock. Nothing influences that. It's going to happen no matter what. So we call those independent variables. And independent variables are always on the left column of a table of values. So here's a table of values. The independent variables are always on the left column. Okay, so they're always the x values. Likewise, independent variables are always on the horizontal part of the graph, which is the x-axis. So when you think of the word independent variable, think of x. Dependent variables are variables that change based on the independent variable. For example, the height of the sun in the sky depends on time, right? As time goes on, the height of it is affected. In the morning, the height of the sun is very low, but as time goes on, the sun gets higher. Okay, so dependent variables are always in the right-hand side column of a table of values. So they're always in the y column. And likewise, they're always on the vertical axis of a graph, which is the y-axis of a graph. Okay, so whenever you think of dependent variables, I want you to think of y values. Okay, for example, the cost of a banquet at Lamplighter Inn is $450 for the room plus $15 for each person served. So what is the dependent and independent variable here? Okay, so ask yourself, there's two unknowns. So the two unknowns are the number of people attending. We don't know if one person is going to go to the banquet or if 100 people are. Okay, and then the other variable, so the other thing that we don't know is the total cost. Okay, so which one depends on which? Hopefully you notice that the cost depends on the person. So the cost must be the dependent variable, and the number of people must be the independent variable. Okay? So if you're having trouble understanding why the cost depends on the number of people, just think of it this way. If you only have one person go to your banquet, the cost is going to be really low. If you have 100 people show up, the cost is going to be high. So the cost depends on how many people show up. So it's always easiest when you're asked to identify the dependent and independent variables. It's easier to figure out what the dependent one is first, and then you know the other one is obviously the independent variable. Okay, so x is the number of people, y is the cost. Independent variable, you just have to set numbers. Okay, you choose them yourself. So for number of people, let's go up by tens. So what would the cost be if 0 people showed up, if 10 people showed up, 20 people showed up? Okay, so remember there's 2 costs involved here. You have to pay for the room rental, no matter how many people show up. And then you need to pay $15 for each person that shows up. So let's go ahead and calculate cost. So if no one shows up, you're obviously not going to pay $15 for anybody, but you're still going to have to rent the room. So the cost is going to be $4.50. If 10 people shows up, you're going to pay $4.50 plus 10 times 15. So it's going to cost you $600. If 20 people show up, you're going to have to still pay $4.50 for the room plus 20 times 15. So it's going to be $750. If 30 people show up, $450 for the room plus 30 times 15. So it's going to cost you $900. And finally, if 40 people show up, you're going to have to still pay $450 for the room and then 40 times 15. Let's go ahead and graph this relationship. I put my number of people on the x-axis because it's the independent variable, and then I put the cost on the y-axis because it's the dependent variable. Okay, let's plot our points. So the first point is 0 and 450. Second point is 10 and 600. 20 and 750. 30 and 900. And 40 and 1050. Okay, so the next question is it a linear relationship? Yes, it is, because it creates a straight line. Okay, but moving forward, I want you to always prove that it's linear mathematically as well. Okay, because this line, sure, it looks linear, but let's actually prove that it's linear. Let's calculate our first differences and see that it'll be linear that way. So take our y values and subtract them. So 600 minus 450 is 150. 750 minus 600 is another 150. 900 minus 750 is 150. And 1050 minus 900 is 150. So because our first differences were all the same, they were all 150, we know it is also linear. So yes, because the graph is a straight line and all the first differences were the same. Okay, so in summary, when you're given a table of values, you guys know how to calculate the first differences, and you know that if all the first differences are the same, it's a linear relation.